All right, so we're going to finish up parameterizing lines and segments. So we did that last class, but now we're going to write line segments, not just that end and, well, not just that start and end at two specific points, but we'll start and end at 2 points for a certain amount of time, and then build on that to like have it go from one point at one point in time to another point at a different point in time. Right? So the first example, so we're going to write a set of parametric equations for a bug that travels from the point -13, 27 to the point 34, -32, and takes 15 minutes to do so, right? So I'm going to show you two different ways. I'm going to show you one way. It's the way that I did it kind of organically, and I put the steps here so that you can refer back to it later. But there's a much easier way to do it, sort of like a formula. So I'm just telling you that so you don't frantically write down notes of the first way. But I feel like if we go through it this way, you'll understand why this way makes sense. All right. So just sit back and listen, and then this is what you want to use going forward. It's just way easier that way. All right. So we got a bug traveling from those 2 points. So we can visualize what that is. Here's an x-axis. Here's a y-axis. All right, it's going from this point at -13, 27 to this point at 34, -32. All right, so it's going in this direction, and it's going to be a line segment. So we have to make sure it has this orientation going from left to right. And we want the time, like we want this to be like starting at time equals 0, and this to end at time equals 15 minutes. All right, now it could start at t equals 1 and end at t equals 16. Could start at t equals -5 and end at t equals 10. As long as there's 15 minutes from one point, from this point to the other point, then we're good. So the first thing I'm going to do is write the equation of the line in two variables that goes from that point to the other point. So I'm going to use point slope form. So my point could be y minus 27 equals the slope times x plus 13, because that's like minus -13. Right? And then my slope is going to be the change in y. So from 27 to -32, that's going to be down 59. So that's the change in y. And then from -13 to 34, that's going to go to the right 47. All right. So this equation in point slope form represents the line, not line segment, but like the line in terms of two variables that overlaps those 2 points. All right, so I'm going to write that down so I have it for reference. So you might want to write it down too, because I'm going to have to erase my screen to, pull up the calculator eventually. All right, so we want to make sure that if we're writing our set of parametric equations that, let me do a different color because I'm doing something a little different. So for x equals t, we want to make sure that it starts, like so when t equals 0. So we're going to make t go from 0 to 15. We want to make sure that when t is equal to 0, that the first x coordinate is going to be -13, because that's the point that we're going to start at -13, 27. Okay, so what we could do is make like another linear equation here, because it's changing, like as t changes, x is going to increase by like a constant each time. So there's like a linear growth between t and x. So I can write this as like our parametric equation for x. And we want to make sure that x of 0 is -13. So we have to solve for m and b. So we got x equals 0 is negative 13. So like we can use that. And then also we know that at 15 seconds or 15 minutes, we want it to be at this point here at 34, comma, negative 32. So since we're writing the parametric equation for x right now, then when x of 15, when t is 15, we want that to be 34. So what we could do is set up a system of equations here so that at x equals 0, we're at negative 13. Sorry, when t equals 0, we're at negative 13 on the x-axis, and when t equals 15, we're on 34 on the x-axis, and then it'll take 15 minutes to go from that point to the other. So we're going to set up a system by plugging in 0 for t and negative 13 for x of t to get one equation, and then do the same thing, 15 for t and 34 for x of t. So I'm going to do that with the calculator. So the two equations I'm going to use are negative 13 equals m times 0 plus b, and 34 equals m times 15 plus b. So I'm going to type that in the calculator now. And then I also have the blue equation written down, this one right here, because we're going to need that later. Now you could solve that system by hand, meaning like by like substituting and eliminating. But since we have the calculator, you might as well use it. So solve, nope, don't do that. We got to solve a system of equations. So algebra, solve system of equations or linear equations, doesn't matter because these are linear equations. We have two equations and our variables are going to be m and b. And our equations were negative 13 equals 0 times m plus b, and 34 equals 15 times m plus b. And we get 47 over 15, comma, negative 13. So let me write that down too. So I'll keep pulling this up. So m is equal to 47 over 15, and then b is equal to negative 13. So back to our parametrics, right? We now know that we're going to let x of t be 47 over 15. All right, and the 15 should sound familiar, 15 seconds, and the 47 is actually the change in x, how much x changes from one point to the other, from negative 13 to 34. And so that's m times t plus b, so negative 13, which makes sense. It's like our y-intercept in a way, like you plug in 0 for t and x is negative 13. So that means that t equals 0, we'll be starting at that point, negative 13 for the x-axis, x and x coordinate. And when we plug in 15, all right, if you plugged in 15 there, you could see that if you did 15 times 47 over 15, that would cancel out. 47 minus 13 is 34. So at t equals 15, we're now at the x coordinate 34, which is what we want. So the second way that I'm going to show you is actually this right here, where instead of going through all those steps that we just did, every time you can make, when you're writing a line segment from one point to the other, you can use this format where 47 is like the numerator of what you multiply by t is going to be your change in x. And 15, we're going to call it h. So h is like the length of time it takes to go from one point to the other. And then this is going to be your starting point. All right. And I'll show you notes on that in a second, or a slide on that in a second. But now to find the y parameter, if you remember, we had y minus 27 was equal to negative 59 over 47 times x plus 15, plus 13. And then since it was like y minus 27, I didn't write that part on purpose, we can add it to both sides and get the plus 27 on this side. So if that's y in terms of x, to find y in terms of t, we could take our expression for x in terms of t and plug it into there. So negative 59 over 47 times x, but since we want this in terms of t, we're going to replace x with this, which is 47 over 15 t minus 13. All right, so that's, I'm just plugging that in right there for x. And then we get plus 13. And then plus 27. So that's how I did this problem originally before I looked up if there was a better way to do it. And when I found the better way to do it, all right, I had the same equation that I have for x, but for y, it was in that same form where it's the change of now y over h minus or plus the starting point. And this is actually like the same exact form if you simplify it, because now if you were to simplify this a little bit, all right, you could get rid of these parentheses here. Then you can add negative 13 and positive 13. And then if you multiplied negative 59 over 47 times 47 over 15t, which is the only thing left inside these parentheses, they would cancel out. And you get negative 59 over 15 t plus 27. And now that's our parametric for y. And it's in that same form as x, where when you're writing a line segment from one point to the other, you're going to do the change in y from one point to the other. So if we look from 27 to negative 32, that's going down by 59. This is h, that's the length of time it takes, 15 minutes. So we're starting at t equals 0 to t equals 15, and this is your starting point. So in the future, when you do a problem like this, and the next one that we do, we'll do what I'm about to say, you can jump like right to this form. All right, so now I'm just going to type that into the calculator and graph it and make sure that we did it right, just because you should always do that. Check your work when it's possible. And I see someone just sent me a message, and I'll read it in right now. And we're going to graph this on the calculator. So the 47 over 15, so it kind of came from two different places. So where it actually came from when I did it was when I solved this system. So I'm going to erase all this stuff, go back to the calculator. So it came from this, where I was trying to figure out what x of t was by saying, all right, well, I know that as t increases, so this is a line segment, like our x and y coordinates are going to increase by like the same amount each time because it's a line. So like the rate of change is constant. So that's why I made this like a line. And I wanted x of 0 to equal the x coordinate of our first point, because we wanted it to start at the x coordinate negative 13 and then end at the x coordinate. So ending mean after 15 minutes. So when t is 15, end at negative 32. So then if you plug in like 0 for t and negative 13, so this should be, I messed that up. So like if you plug in 0 for t and then negative 13 for x of t, you get one equation, but with two variables, m and b. And then you plug in 15 for t, and then negative 32 for x of t. Then you also have two unknowns, m and b. So then that's why we did that up here. We saw the system and found what values for m and b would make that work. Now, you don't ever have to do it that way ever again. I just want you to see like that, this right here on slide 19. And slide 18 explains how I did it the first time. And again, you could probably never read that slide again. This is what slide 19 right here is what I need you to use going forward. If you want to do it the way on slide 18, that's cool too. But so in general now, when we write the parametric equations for a line segment, we could just use this as our model. And I always give this to you. You can use your open notes if you ever have a test on this stuff. So when you're writing a line segment from one point to the other, if x1 and y1 is the starting point, and x2, y2 is the end point, all right, x of t is going to be the starting point plus the change in x. So from the starting point to the end point, what's the difference in x divided by h, where h is the length of time it takes to go from the starting point to the end point. And then t is just that third variable for our parametric equations. And then you could do the same thing for y. So y equals the starting point for y plus the change in y divided by h. So the change in y is the change in y from x1, y1 to x2, y2. So pretty much y2 minus y1 divided by length and time plus t. All right. And then just to see our work come to fruition, let's just graph what we had. So add a new graph, parametric equations. All right, so what we had was negative 47 over 15 times t minus 13, and then parentheses negative 59 over 15 times t plus 27. And we'll make our t step go up by 1 each time because we're not really dealing with angles. So when it's not dealing with angles, you don't have to make it like something in terms of pi. You can just make it go up by 1 each time. And our time period is from 0 to 15. And we gotta zoom out to see that whole segment. So before I even trace this, just to compare it to this, what's behind the screen. So we have x of 1, that's the starting point. So we remember what the question was. We're starting at negative 13 comma 27. So that's why there's a negative 13 there and a 27 there. And then what we multiply t by is the change in x divided by, between those 2 points, divided by the period of time that's going to take to go from one point to the other. So that's why both of these are over 15, because it's always going to be the same number because it takes the same amount of time because they're both the same points. It's just one's x coordinate, one's a y coordinate. Then the 47 is the change in x and the 59 is the change in y. So if you look at these 2 points from negative 13 to 34, that's a change of positive 47. And from 27 to negative 32, that's a change of negative 59. Now, if we trace this, right, t equals 0, starts at that point. And then if t is in minutes, so yesterday or last class, someone asked, like, is t in seconds, is t in minutes, is t in an hour? Sometimes you don't know if there's no context of the question, but in this case, we're going to let t be in minutes because that's what the context of the question says. So after, once t reaches 15, now we're at that end point. All right, cool. So let's do another one of these, but instead of going through all the steps that we did the first time, which I think is good to do the first time, just to kind of understand that this is not just some magic formula. It does kind of stem from something that makes sense. It's not just a random formula. Now we can just use this going forward. All right, and here's just screenshots of the graph that we just did. All right, so for 21, Yeah, I'll be posting this on YouTube, assuming that it records. So sometimes I promise, all right, sometimes I forget, so that's my bad. But a lot of times I don't forget and I record the lesson. And then when I like download it to upload it, like download it off Zoom, it like something crashes. Or if I use Screencastify, it just doesn't work. So I can't control that. But my intentions, I'm recording right now, is to upload this video. But who knows if I'll make it there. I'm saying every time I record it, it's like 60-40, 60% of the time it works, 40% of the time it doesn't. But technology will get better over time. But right now it's still not working great. But yes, hopefully this video will be uploaded. And if it's not, we can do another day of this. We'll take our time. If you guys ask questions, I'll slow down and address whatever needs you have. If you don't ask questions and you keep submitting the homework and it looks good, I'll assume that you guys understand everything and keep moving at the pace that we're going. All right, so 21, I'm just gonna straight up use this here. All right, so if you wanna write that down for a second so you know what I'm talking about when I do this problem, you can write that down right now. X of t equals x sub 1 plus delta x, the change of x, divided by h, and then that whole thing times t. And then y of t is equal to y sub 1, where x1, y1 is the start point, plus delta y, that's the change in y from one point to the other, divided by h, that's the length in time, times t. All right, so for this one, I'm gonna go right into the calculator. Oh, come on, I just wanna look at one slide. Sorry, I can't make it bigger. Won't let me. So I'll just do this. So it takes 3 days. So now t is in days to go from negative 41, comma 20 to, so in the direction from negative 41, comma 20 to negative 9, comma negative 2. All right. So we can open up a new calculator, control plus page, add a calculator. Check, I messed up, should be a graph. So do it again. Make it parametric equations. So go menu, graph entry edit, parametrics. All right, now if we jump to the bottom real quick, our period of time is going to be from 0 to 3 days. We'll change that from 0 to 3. And our t step, we'll just make it 1. Oh, looks like my daughter's getting up. Hopefully she goes back to sleep. Won't worry about that right now. She's fine. She's safe in her crib. But anyway, so it's going to be the starting point for x. So that's at negative 41 plus the change in x. So from negative 41 to negative 9, if we subtract those two numbers, 41 minus 9 is 32. So, and it's going to be positive 32 because it's going from negative 41 to negative 9. So it's going in the positive direction. So the change in x is positive 32. Right, divided by 3. That's the period of time that it's going to take to go from negative 41, comma 20 to negative 9, comma negative 2. And then times t. And then for the parameter y in terms of t, right, the starting y coordinate, the starting point is negative 41, comma 20. So starting y coordinate is 20 plus the change in y. So from 20 to negative 2, that's going to go down 22. So negative 2 minus 20 is negative 22 divided by 3. And t. All right, and I'm going to move the screen or just zoom out a little bit to see that. And so if you think about this formula, it kind of makes a lot of sense. So I'll explain what I'm saying by tracing it. So if we look at t equals 0, right, and I want to see that whole formula. Trace. Right, so t equals 0, right? So if we plug in 0 here and 0 there, right? The 32 over 3 times 0 is just going to be 0. And the negative 22 over 3 times 0 is just going to be 0. So that makes sense that when t equals 0, we're going to start at like whatever the constant is, like so negative 41 in the x equation and 20 in the y equation. And then the change in x to go from negative 41 comma 20 to negative 9 comma negative 2, the change in x is 32. So you move 32 over in the x direction from one point to the other, and you're going down 22. So we only want it to move that much, like 32 to the right and down 22 after 3 days. So that's why we put it over 3. So when t is equal to 3, that's when you plug in 3 for t, and that will cancel out and add that full change in x and full change in y. And then since it's a line, like the ratio of how many days to 3 days will be like the ratio of what % of the line you've traveled. So like after 1 day, you would have gone like 1/3 of the way through this line, because now instead of moving 32 units to the right and 27 units down, you're moving like 1/3 of 32 across and 1/3 of 22 down. So that's why that makes sense. All right. Cool. No questions? All right. Let's look at number 22 now. So we have two objects, object A and object B, and they travel according to the parametric equations below. So there's A and there's B. So compare the starting points, the orientations, and the speeds. All right, now you could do this on the calculator, but first I'm going to show you how you could think about it without even graphing it and answer all these questions. And I'll show you how to confirm it with the calculator. And you can always use a calculator for all of these. So practice using it when you do these problems, whenever possible. All right, so the starting points. All right, so starting point, if there's no like range of t given, you know, you're implying that you're going to start at t equals 0. Like you start counting at 0, and then every second or minute after that, you just add another to t. All right, so the starting points are just going to be like the coordinates for x and y, where, because we're still graphing on an x and y axis, t is just this independent variable that like controls x and y, but the points are still x comma y. So if you plug in 0 for t, like cancels out, cancels out, cancels out, cancels out. All right, both of these have the same starting point. They're both going to start at negative 12 comma 5, negative 12 comma 5. All right, so you could do that just by plugging 0 in for t, or if they give you a range of t, then whatever the lowest value of t is, that's where you would start. Unless they specifically say to start somewhere else. Now, we can easily confirm that with the calculator by just graphing it and just plugging 0 in for t and seeing where they start. All right, the orientations. So these are going to be line segments. So like a line segment, you know, unless it's vertical, if it has like a positive slope or negative slope, all right, it's either going to be going from left to right or right to left. So we'll get into other ones like parabolas and ellipses where orientation is a little more to describe. But like you're either going to describe it as going from left to right, like in both of these cases, it's going from left to right. Or if it's going like the other way, like that, then you could describe that as right to left. So how do we tell without graphing what the orientation is? Well, look at the slope or like the coefficient in front of t. All right, since this number is negative, as t increases, so as you increase t, when t goes to 0, that's going to be negative 12. All right, but when t is 1, that's going to be negative 12, like minus 9/6, which means every time t increases, x is going to decrease because you're going to subtract more and more from it. So just from that, I could tell that it's going to go, as t increases, this is going to go from right to left in A. Because as t increases, x is going to decrease, and on the x-axis, from right to left, that's where the values on the x-axis decrease. And by the same logic, for this one, as t increases, since that coefficient in front of t is positive, all right, x will increase. So this will go from left to right, just like on the x-axis, the values increase when you look at them from left to right. And then we can also look at that coefficient to describe the speeds, all right? Now, speed is kind of separate from direction. So like if I was walking 2 miles per hour from left to right, and you were sprinting 10 miles an hour from right to left, we're going opposite directions, but you're moving faster, even though you're moving in the negative direction. So you don't really have to worry about the sign when you think about the speed. It's just like how much is x and y changing every time t increases. So the speed, and it's a little harder to tell without the graphing it. So you can always graph it on the calculator because there's like x and y. But if you look at the x, like this slope, this number in front of t would be negative 1.5. And this would be like approximately like 0.35. I'm just guessing, it's probably around there. So probably a little less, but nonetheless, like the absolute value of that is bigger than the absolute value of that. So every time you increase t by 1, parametric equation A, x is going to change by 1.5. So as the time increases, the points according to the x-axis are going to move 1.5 units. But for B, it's only going to move 0.35 units. So if you had to compare these speeds, I would say that A is moving at a faster speed. All right. So now we can kind of do all that with the calculator just by graphing and checking. So just keep adding more pages. So if you do this along with me, you can add a graph, go menu, graph entry edit, change it to a parametric. All right, so the first one is going to go from negative 12 minus 9/6 times t, and then 5 plus 4/6 times t. All right, so you don't see that yet. It's probably out of the viewing range, or maybe I typed something wrong. Oh, looks right. And then for the other one, we'll go negative 12 plus 9, parentheses, 9/24 times t, and then 5 minus 4/24 times t. And that looks right. We're going to now look at these. So I'm going to zoom out a little bit, and it's easy for me on the computer, but you can also, like, if you ever grab this, like hit this arrow and like click down, you can like kind of grab the screen and drag it. It's not as easy to do on the calculator, on the handheld calculator, but it is easy to do with my thing. So that's why I don't do it a lot, but I just want you to know that that is an option. All right, so if we start with the speed, I could tell that the purple one, so that was A, is faster simply because both of these parametrics were graphed over like the same length of time. So the green one, that's how far it travels in 6.28 seconds. That was like the default that the calculator gave me. And same thing with the purple one, like it's graphing it over 6.28 seconds. So if we were running a race, and I said, all right, start sprinting, for 6.28 seconds. And then I said freeze after 6.28 seconds. The person who ran the green distance is clearly slower than the person who ran the pink distance. And I'm pretty sure they overlap. Not that it would matter. Yeah, so there's the purple one, and then they had the same starting point. So yeah, they should overlap. So the purple one is clearly faster, moving at a faster speed because it travels the longer distance in the same amount of time. So a great way to compare speed is just to graph two parametric equations over the same length of time, like we did here, 0 to 6.28, and see which one moves farther. All right, that's all you gotta do for that. For orientation, all right, you could trace it. So go menu, trace, graph trace, and then just look at what direction is going as t increases. So the purple one goes from left to right as t increases. Okay, and then if you hit up arrow, you can see the other graph. And as you go from left to right, or as t increases, this graph is going from left to right. All right, so that's orientation. So that's the direction that the arrow should go. For the green one, downward from left to right. For the purple, pink one, upward from right to left. And then the starting points, you could just type in t equals 0, or type in 0, and then see, all right, that one starts at negative 12, comma 5 when t is 0. And then this one also starts at negative 12, 5 when t is 0. So that's how you do all that with a calculator. All right. Okay. So for this one, we're given a set of parametric equations, and we have to modify it so that it takes 20 seconds to travel between those 2 points. So what do we need to do that? Well, we need to know the starting point. All right, so we're going to use this here. We need to know the change in x from when it goes from the one point to the other point. And we need to know how long we want it to go from one point to the other point. So we're going to use this to create our new parametric equation. All right, so for the starting point, so like x of t equals our starting point, and y of t equals our starting point. We can find our starting point. Well, we're given that. This is going to go from negative 17.11 to 13.5. Now, it doesn't say which one that it starts, so you really could go either way. It doesn't really matter. But, so we'll just do the first one. We'll assume that's the starting point. Negative 17 and 11. Okay. Then plus the change in x. So this is really irrelevant. We don't really need to use it because we can tell the change in x by just looking at these 2 points and the change in y by looking at the y coordinates of those 2 points. So the change in x is going to be 30 because 13 minus negative 17 is 30. So plus 30. And the change in y is going to be down 6 from 11 to negative 5. And then h is the length of time, so 20 seconds. And then just times t. Now the reason why this is kind of irrelevant to the question is only because we're assuming that, well, and we have to assume that like this set of parametric equation does go through those 2 points. It's like they already created a set of parametric equations that goes through those 2 points. But because we have the 2 points, that's all you need to find the starting point and like the change in x, change in y, and then they give us the time period. So, right, so that's all you would do for number 23. All right, so we're almost done. Try to get you out of here in 10 more minutes. So I just want you to try these last three here. And I'll do my best to go over them in the time we have left. But 26, I mean, they're slightly different than what we've been doing. But I think you can figure it out. Might take some thinking. So if you want to just, so you know what, I'm going to end the recording here because then there's going to be me waiting for you guys. Let me at least pause it.